So thank you so much for coming. It's afternoon, and it's security topic. So really, really thank you. I really like that security continue to be #1 priority for you. We will be talking about interesting areas. We will be talking about security of our infrastructure, not only services that we will provide for you, our customers, to use. And again, let us start. Not only I will be on the stage, it will be 3 more speakers with me. So I'm Nelly Porter. I'm Senior Product Manager with Cloud Platform Security Team. And Jasika Bawa, she will join me a little bit later. She is also Product Manager with Cloud Platform Security Team. We also have 2 additional speakers, 2 vice presidents with us, so we slightly worry. And one of them is Steve Gold. He is Vice President of Hyper Security Solution that some of you probably know by this 3-letter acronym called CIS. And he will explain what it means if you don't know. And with us also Raphael de Cormis, and he is Vice President of Innovation Labs in Gemalto. So both of them will tell you about our partnership and what we've done together. So let me start, and before I will start, there is a live Q&A that we will not be doing. So we will use Dory instead. So please submit all your questions, and here's the quick instructions. And because all of you security experts, I know that you would be able to figure out how to post your Dory questions. If we will not have enough time during the session, we will answer them as well, every single question. So please, please, please submit them during session. Oh no, focus on the session, maybe after that is also okay. So before I will start my part of this presentation, I want to remind you that the motivation of security, as you probably know, because our adversaries, our bad actors is becoming very, very sophisticated. And usually their motivation is to go after your data or data of your customers, your resources to mind and do what they need for their adventures and their things, and also for credentials to get access to your resources or to your data. And again, sophistication of our adversaries becoming quite amazing in some respect, because if, again, someone will spin up VM and make it available to internet, we've seen the SSH access literally in 4.6 minutes. It's not always successful SSH access, but it depends on your credentials for that. So they regularly crawl GitHub to find your keys or passwords or any other credentials, and as soon as anything is discovered, it's used literally in a few minutes. There is a very interesting paper that was published in 2017 about the life of exploit and what is motivation for all of those exploits, what is the driver in that. And again, very often when I'm talking to customers, and I actually do that very often, some customers telling me that all these advanced persistent threats is not what their primary focus is. And the reason why, because all the state actors are not going after them. It's a small company doing something very reasonable, why do they? And what I am kind of failing to explain and continue to explain again and again is that you don't need to be a big fish to be a target. The problem with, again, all of these exploits, today they can be packaged in different form and used or even leased as exploit as a service in literally very affordable price. It's $150, $200 for 2-3 weeks of use. So what do we do about that? And in Google, we strongly believe that there is no one absolute security solution that will solve every single problem. We strongly believe that it's, again, the necessity to have the defense in depth on every single layer. And in our infrastructure, something that you probably don't see because it's below the line of your visibility, we spend significant amount of time and efforts to secure the infrastructure. And it is very important to us because customers and users consume this infrastructure every single time they interact with Google product. So let me start from the lowest level of our infrastructure. And you probably seen already this small chip, this, again, 1-to-1 square. You can pick up one in our demo over there in exhibition. But it's not real Titan, so don't get your hopes up. So the real Titans that we produce, we actually keeping quite secure. And the Titans giving us a lot of power. Those chips, it's secure, again, cryptography-based chips. We design with our Google scenarios in mind. And because we control our custom hardware, we have opportunity to use it in the way that we believe will provide the best advantage for us, Google, for our infrastructure, and for you, our customers. So the first interesting use case, I guess, that Titan help us to provide is what we call machine identity. And machine identity's idea here is very simple. When we manufacture those chips, we put in the fuses, and it's the place in your ASIC that actually cannot be extracted, the keys that we call Titan identity key. And after that, we derived an additional, again, public-private pair of keys, with private keys keeping in the same place, and again, issue certificates for those keys. We have the list of all of these Titan identity keys in our Titan registry, and our Titan certificate system, or Titan CA, is actually running offline to issue certificates to those Titans. So now when you put this Titan chip on motherboard, or you put this Titan chip on our network card, you have opportunity to challenge, I'm talking about cryptographic challenge, these particular machines or these particular peripherals. And what we do, we ask in Titan to prove the again, possession or the fact that those keys are still there where we put them initially, and sign the challenge. And that's what Titan does. And then we can validate that those machines is actually our machines. Those machines that we have in our Google data centers is what we believe they are. The additional things that Titan offers us, it's what in industry we call secure boot. And secure boot is very interesting idea, very old idea, I think. The idea is that you need to run what you believe is not tempered. You need to run code or functionalities that nobody changed. And what you expect to run, you have to run. And secure boot helping in this respect because it's actually loading only and only signed binary. And it means whatever we as Google produce those binaries, we know that it's not changed. And the third piece of this puzzle is measured boot. So measured boot, the idea here is that we also validate that every single binary that we want to boot is actually booting, but it's also giving much more granular information. It's giving us opportunity to figure out that despite of the fact that some binary probably sign, but again, older, it's not the binary we want to boot. Or if the order of the loading sequences change, we'll be able to figure out it. One additional thing for Titan, it's almost the same, again, we in San Francisco, real estate is hot. It's like real estate, it's location. So Titan has very interesting location. It's sitting between Platform Controller Hub, PCH, and Flush. And it's also keeping CPU at reset. And it means when we boot up our platform machine, what will happen when PCH is trying to read BIOS from Flush, All of this communication and all bit-by-bit instruction going through the spy channel when Titan have ability to validate the first instruction before CPU will get up and will be executing that. None of security chips today on the market is actually capable of providing this capability. We called it first instruction integrity. And we believe that it's critically important to test or verify before you will run. So as soon as Titan validated bias, the trust chain is established and bias is validating bootloader. So no surprises, bootloader is before it's starting to load kernel is going and validating every kernel module that we need to load in our production kernel. And after it's done, we validate our file system. When all of these checks done, we know that we have a time to put or lay our hypervisor. And we're using KVM, as you probably know, it's type 2 hypervisor, but we've done a lot of hardening in our hypervisor. We actually published blog about what we've done. If you're interested, please go read it out. We try to make it as entertaining as possible, but to summarize, it was, again, 3 important things that we've done with KVM. We reduce the attack surface. We took out a lot of drivers that in cloud environment, we simply never will use. And because we have more or less architectures that we control, we can remove a lot of, again, code that we simply never will use. And in security, you know exactly as me, as less code is better. And that's exactly what we've done. Additional things that we've done, we rewrote QEMU. So the last 5 years of CVEs in KVM all were concerning QEMU. So we rewrote it, and the goal for us not only to get rid of and create new bugs, but the goal was to make and move a lot of emulation of device drivers to user mode, because explosion and exploiting kernel mode is actually much more painful and much more catastrophic. And also we've done a lot of security reviews of open source KVM code and submitted quite a few bugs from our side as well. And with all of this work, with all of this hardening, the time came and we bring your VM. And the biggest security issue is how easy it is to spin up a VM. So with all of this knowledge and with all work that we've done on infrastructure, we decided to introduce yet additional service that you as our customers will use. We called it Shielded VMs, and Jasika will let you know what it means.
Thank you, Nelly, for that awesome background. First and foremost, I'm really excited to announce that here at Next, Shielded VM is officially generally available. So we've been in beta. This is our official graduation, so we're now GA. So before we get into it, just a quick word on what exactly is Shielded VM. So the reason we kind of went through that background to look at how exactly we have secured our infrastructure platform layer is to kind of tee up why exactly we built Shielded VM as a service made available to our customers. So with Shielded VM, so what exactly is that? Shielded VMs are essentially Google Compute Engine instances that are well configured to provide you with some of the security guarantees that we just discussed, to protect you against the most advanced threats at the lowest level, including rootkits and bootkits. With Shielded VM, we want to enable our customers to be able to ensure that their workloads are trusted and verifiable. And we also want to be able to expose functionality that helps you protect your most critical secrets against exfiltration and replay. So let's take a quick look at how exactly we can meet some of those promises. So this diagram should hopefully look a little familiar because we looked at a similar version of this when Nelly talked to us a bit about chain of trust and how exactly we have built that chain of trust to secure our infrastructure at a platform layer. So what we've done is we've taken our learnings from that and we've sort of bundled it into this service that we've made available to our customers, which is Shielded VM. So right from the bottom layer, we start with, we've replaced your old and trusty, rusty BIOS with UEFI. With UEFI, that now gives us the possibility to offer extensions like secure boot and measured boot, which Nelly talked to us a little bit about. In addition to UEFI with secure boot and measured boot, we've also gone ahead and built this implementation that we call vTPM. So this is a virtual trusted platform module. So you can think of it as a virtual version of TPM, or Trusted Platform Module. In fact, our vTPM implementation fully implements the TPM 2.0 spec. It's signed off by the Trusted Computing Group, and it's FIPS compliant. So you can sort of think of this vTPM as a TPM. The reason that we do not use a hardware TPM and we instead use this virtual TPM for Shielded VM is to be able to empower you to do all the things with Shielded VM that you would do with a regular GCE VM. And that specifically includes live migration and live patching. That wouldn't work if we used a hardware root of trust, and so that's why we are using this virtualized root of trust. So we have our good vTPM. And then finally, one of the coolest things that I think we've added to Shielded VM is what we call integrity monitoring. So you have your secure boot, measured boot, vTPM working for you, but you don't want to be SSHing into every single VM instance trying to figure out, hey, has its integrity state changed since the last time I looked at it? So what we've done is we've actually built a service around this for you. We export all the relevant registers as necessary, and we convert it into a single bit that we put into your Stackdriver. So therefore, that means that all of this logging is going straight to Stackdriver, and you just need to look at Stackdriver to know whether the integrity of this particular VM instance has changed since the previously known healthy baseline. So with that all said, we have all our architecture laid out. So that means that we can actually deliver on the following security assurances for Shielded VM. So specifically, we're looking to guard against malicious guest operating system firmware, including malicious UEFI drivers. We're looking to guard against the malicious guest OS itself, specifically looking at the potential for boot and kernel vulnerabilities in a guest VM. And then finally, we're looking to provide some protection against potentially malicious insiders within your organization with the help of that good vTPM functionality that we discussed that can help you seal secrets and make sure that they're only accessible when directly interacted with the vTPM. Because the vTPM is outside of the trusted security boundary of the VM, which means that if your VM is compromised, the secrets within the vTPM are still safe. So that said, we're going to try and move into a quick demo. Awesome. So I just want to show you really how easy it is to spin up a new Shielded VM and how similar it should be for any folks that are familiar with Google Compute Engine. It should really look like almost the same to you. So here we are in GCP, our Google Cloud Console. I'm going to go ahead and click on Create Instance over here. And first, we got to give our instance a cool name, because that's the most important part. So now all we got to do is we have to look under boot disk and make sure that we're switching this boot disk to a shielded boot disk. And we try to make this as easy as possible for you with this handy checkbox over here that filters out all non-shielded images and only shows you the shielded image options. So let's say we go ahead and pick our CentOS 7 over here. I'm going to hit select. And so we have that boot disk over there. Now, I really quickly want to show you under the security tab over here some of the features that we just discussed. So we talked about integrity monitoring. We talked about vTPM. We have these turned on by default for you. We also have the option for secure boot. We've actually decided to have this opt-in for specific customers that have potentially custom or unsigned drivers that might have compatibility issues with secure boot. So we leave this up to customers to opt in. But if you do not have that compatibility issue, we definitely highly recommend that you turn it on so that you can get all of the security guarantees that we just discussed. And that's it. You go ahead and hit create, and that's pretty much all that it takes to spin up a new shielded VM. So really, hopefully, you should see that this is very similar to your regular VM spin-up flow. Because I don't want to hold you here waiting for the VM to spin up, I spun up a VM previously, this cool instance. I just really wanted to show you really quickly some of the logging that we had discussed around integrity monitoring. So as you can see here, we have our Stackdriver logging. We're just going to go in here, and we can filter just to the shielded VM integrity logs. So these are the logs that we talked about before. These are tamper-evident logs because they are signed by our vTPM. So now over here, we can see some of these integrity events. Let's go ahead and look into one of them. So here under our JSON payload, you can see the single bit that I had mentioned earlier. So this is kind of our summary of investigating all of the registers that we've talked about earlier, and we've condensed that into a single Boolean bit. If the integrity had changed from the previously well-known healthy baseline, you would actually see a false here. So this is interesting. And then, of course, if you are actually interested in the values in all the registers, those are also all available to you in the log. One other quick thing that's worth looking at here is that you can also establish the provenance of the instance that you're looking at. So here under resource, you can see specifically the instance ID that I'm looking at the integrity logs for. You can see the project ID. And finally, you can also see the specific zone that this instance lives in, so you know that this is the exact instance that you were interested in looking at in terms of the integrity logs. So that's our quick demo on how easy it is to spin up a new shielded VM and check out some of that monitoring. Now, of course, since we're writing that message out into Stackdriver, you can definitely create custom actions based on what you see in that bit. So for example, if you see it switch to a false, you can potentially write a cloud function that stops that VM instance before you go investigate it. Similarly, when you do go investigate that change in integrity state, if it's something that was caused due to something expected, so for example, you have updated your kernel or you have an updated kernel driver, that would in fact cause the integrity state to change, but in that case, it would be non-malicious, so that was something expected. In that case, we have APIs available for you to add that new baseline as another known good baseline to the list of good baselines, so we won't alert you on that again. So that way you can sort of filter out some of that noise. So let's switch back to our slides here. I just want to do a quick recap on some of the things that we've learned here about shielded VM. So we looked at the experience that we looked at here was our Google curated images. So most of your favorite operating system images are available as shielded VMs as well. So this includes CentOS, Ubuntu LTS, of course, Windows. We have RHEL, and finally our container optimized OS, and we're always expanding this list. So folks that have been following us since beta would probably notice that we've added some operating systems here. We also have shielded VM images available in the marketplace, and Steve's going to talk to us a little more about that. We built these in collaboration with our partner CIS, and so these images actually bring you the best of both worlds because they're shielded as well as hardened, and Steve's going to talk to us a little bit about what that hardening thing looks like. Finally, if you do have custom images that you want to turn into shielded, as long as they support the specific features that we need to have a shielded VM and to have the integrity monitoring service work, for example, we discussed UEFI, we will be providing a method for you to bring your own custom images and make them shielded and take advantage of the shielded features that way. We looked at the simple one-step spin-up from the Cloud Console. Everything that you can do in the Cloud Console, as with all GCP features, you can do it from gcloud, and you can also do it from API. It just doesn't make for as good of a demo, so that's why we looked at the Cloud Console today, but definitely all the functionality is available via all three. We talked about how we built this feature from ground up with support for live migration and live patching in mind. This is something that's really important to us as a cloud provider in addition to our customers. We've definitely used things like live migration and live patching in the past to patch issues like Spectre before our customers were even aware of them. So this is definitely a functionality that we want to continue to support, and that's why we've made sure that Shielded VM is completely compatible with this, low latency. And then finally, for our GA, we've also gone ahead and added a new organization policy For customers that are a little more security-minded and want to lock down a specific project or even at an organization level to say newly spun up VM instances should all be shielded. So you can actually go ahead and enforce that now. And then we have IAM roles and permissions to lock down on who in your organization actually has the capability to flip some of those security functionality settings that we looked at earlier. And finally, one of the questions that we always get after this pitch is, how much is it going to cost? We're happy to say that shielded VM images are available at no additional cost to you. So whatever you would pay when you're spinning up a new GCE image or purchasing an image from the marketplace, there's no markup for shielded because we want to integrate that security by default for you. So that said, I'm happy to hand it off to Steve, who's going to talk to us a little bit about our partnership in bringing shielded and hardened images to the GCP marketplace.
All right. Well, thanks, guys. Thanks, Jasika. So CIS, I'm going to talk a little bit about some of the hardened images that we have in the marketplace to try and help you with your security fights that we have every single day. For those of you that are not familiar with CIS, we are a nonprofit organization that works with the global community to try and define best practices for securing systems. And we'll talk a little bit more about that as we go through. I guess maybe before we start, show of hands, how many people are familiar with CIS or are using our benchmarks? That's a lot of hands. Okay, so now let's expose the people that I need to talk to afterwards. How many people are not familiar with our benchmarks? Okay, excellent. So I've got your names now. One of the things that I thought Nelly put up that was great was that the biggest problem that we're all having from a security perspective is how easy it is to continually spin up new images and deploy new applications and deploy new infrastructure. And as you can see from this quote from Gartner, that as we grow, a lot more of these problems are going to be your problems, which are our problems, right? So security is a shared responsibility. We all have our part. Google clearly is doing their part by creating the shielded VMs, and CIS is we're trying to do our part for you to try and help you with your part of the shared responsibility, and starting with a secured image or a hardened image to work with these shielded VMs. And we'll talk a little bit about that in how we harden them. So CIS's approach to security really is three areas. So we have our CIS controls, we have our benchmarks, and we have the CIS hardened images. If you're not familiar with the CIS controls, they're a prioritized operational plan to increase your cybersecurity posture. It gives you a start point, it gives you a midpoint, and it gives you an end point, and allows you to walk through that process and create a more secure environment. Our CIS benchmarks are what I talked about earlier, where we are managing a global community of people to try and define the best practices. So the people that are using the systems are the people that are helping us to define the best practices for securing those systems. This is not a manufacturer defining what the best practices should be for their operating system, and it is not CIS defining what those best practices are. It is you people defining the best practices for them and coming to a consensus and seeing where we go. And the hardened images are really just an actualization of that benchmark. We're taking that benchmark, we're applying it to an operating system in the cloud, and then you guys are using it to run securely. So when we talk about how our controls and benchmarks are created, each and every one of you can be part of our community. We do have people from the manufacturers, so people from Microsoft are helping to define the best practices for Microsoft, but we also have CISOs and ISOs and other subject matter experts to try and help us define those to come to that consensus. We do that with our controls as well. So it is vendor agnostic and it is consensus based. So for the benchmarks, I put up an example of what the Windows Server 2016 benchmark looks like. There's over 270 recommendations. If any of you guys would like to download this, you can go to our website for free and download it. I would recommend against not printing it because it's 800 pages in its PDF format. Apparently there's one or two gaps in the security of Windows Server 2016 that we found. So I put up just some examples of some of the items that the community came up with to define as things that we should make better within that benchmark. So as I mentioned, what we do is we take that benchmark and we apply it to that operating system that's living within the Google Marketplace, and then that creates the CIS hardened image. All right. So from a hardened image perspective, you've obviously got a lot of benefits. You've got the benefit of now moving to the cloud to not only run in a shielded VM, which is hardware secured and provides a lot of capabilities at that root level, but now you also have a hardened version of the operating system. So moving to the cloud is significantly more secure when you use a hardened image, because you don't have to spend the time or the resources in trying to figure out what it is that you want to do for that instance to make it run. You can literally just out of the box use this device, use this hardened image, and then start secure. You've got cost-effective and secure computing solutions. It's ready to deploy in minutes, obviously available within the marketplace, and thanks to Google, there's no additional cost to use the shielded VM capabilities with the CIS hardened images. So our tagline is to start secure and stay secure. Obviously, with the shielded VMs and the CIS hardened images, you are able to start secure in the Google Cloud. And then through that process, through that integrity monitoring, you're able to stay secure through that. And we've listed just some of the operating systems that we have currently available for those shielded VMs. So as I mentioned, this is a shared security model that we have to use. And what we're trying to do is bridge the gap between what Google is doing and what you guys are doing by providing you with that hardened image. All right, well, that was really all I have, guys. We have some information about our community. So if any of you guys would like to join our community to either help define some of the benchmarks or some of the best practices for securing operating systems, or if there's a benchmark that we don't have that you would like to see one for, you can create that community. And then as long as you're willing to participate in it, we can start to help and build those benchmarks as well. All right, well, thank you very much, Jessica. I'm going to give it back to you.
Thanks so much, Steve. And I did see a question on the Dory specifically about CIS, so glad that we could answer that for you. I'm really happy to introduce Raphael, who is from Gemalto. We have partnered with Gemalto since the very early days of Shielded VM. So any fans in the room that have been following us through our beta, we've been working with Gemalto. And so I'm really happy to introduce Raphael. Here you go.
Thank you very much. So good afternoon, everyone. I will be happy to give a bit of feedback and return of experience of using Shielded VM for our application and our discovery and partnership with Google. So just a quick word of introduction. So at Gemalto, we are cybersecurity company, a French one, created 30 years ago, and we initially started with chipset security. And it's very likely that half of you in the room have one of our products in the pocket, either in the form of a SIM card, a payment card, or an identity document. So as hardware is moving to software, we are working hard into our own transformation, into providing other services, and they are all around digital identity and data protection. So why a shielded VM is important for us, and how did we use it? So first thing, we'll go back a bit in time into the old days of mobile phones. So we are providing identity for telco customers, and their problem is to be sure that they know their subscribers in order to bill them. So that's their pain point. So with the SIM card and in the backend, some authentication server, we are able to give connectivity when the user is turning on his phone. So this was quite simple. The backend was in a data center, and we did have a bit of spike in the traffic by Christmas time, but more or less it was an easy life, and we could go fishing. But as everything is progressing, and as we see a wave of IoT devices coming up, and as we see also new protocols coming up in 5G, this is really changing the paradigm, and that data center cannot be used anymore. And we did move our solution to the cloud, especially Google Cloud, for scalability purpose. But the main point is to be sure that we do that at the same level of security and the same level of compliance, because all those authentication for network operators are compliant to the GSMA, which is the Association of Operators Providing Security Guidelines. So if we take an example of smart grid, we do have sensors that are connected, and we do have a connectivity which is event-based. So we will get authentication requests coming from the servers, coming to the servers at any given time. So for example, if the weather is changing in an area, we'll have a surge of connectivity requests to the network, and we have to be sure that we are able to handle this load. So hence the scalability of the cloud. But then, to guarantee the security and the compliance, we had to work and be sure to improve our solutions and using the capabilities of Google. So why did we use Shielded VM? For us, it was bringing two things. The first one was a secure boot, and the second one was the sealing of data. So in the end, what are the benefits we could take from Shielded VM? So the first one is to have data protection, especially getting closer to data protection in use, using secure boot to be sure that nothing's happened to the machines we are launching on the cloud. Second, it was really seamless integration, and it is really as easy as in the demo in production, and it's really we didn't have to redo anything either on our cloud workload, either in our own application. And finally, the third thing is to be compatible with our own root of trust and having the capability to import our keys from our own HSM as a service and protect them with data sealing from the vTPM. So thank you again for Shielded VM, and I hope you will enjoy it as we did.
And a few more points that we want to, again, leave with you as well. That we started, again, the Shielded Computing Vault, and we definitely will ensure that your VM-based solutions will be secure. But we are not stopping there. We absolutely want to extend it to any VM-based services that Google Cloud provides. And it means everything that you're using, surprisingly enough, running in the VM, so most of our services, to ensure multi-tenancy support that we have using our VMs. So moving and supporting multiple services is the work that we started. So Shielded VMs is our first step toward Shielded Vault or Shielded Compute. But the next step for us is to provide even more guarantee and more security for you, for customers, than bringing or planning to bring your sensitive data to cloud. And we understand that it's a very difficult decision and very difficult move. So to make it a little bit better, we need to acknowledge that we kind of really appreciate the fact that you trust us. We think that it's very important that you trust your cloud provider, but honestly being very respectful and very, again, understanding security cloud provider, we believe that if we will remove the necessity of you trust us and move our wonderful trusting relationship to cryptographic relationship, we will be all better. And as a result of that, we want to start introducing and talking to our customers about confidential compute. And confidential compute is a new term that industry is actually talking about. The technology is still in very early stages, and multiple CPU vendors, Intel, AMD, and ARM with trust zones, are offering some solution for this problem. And the problem is how to ensure that you can isolate your workload such way that even us cloud providers would not be able to impact your workloads with our own bugs. So there is 0 days always exist in the vault, and we understand that it might be a situation that those 0 days will be exploited. The second thing, we strongly believe that our insiders, people that support your products, are absolutely trustworthy. But we don't want to ensure, or again, we want to ensure that their credentials being spoofed or phished would not be used in malicious ways. So we don't want you to rely on our insiders maliciously or mistakenly leaking your data. So what do we need to do to ensure that those very high security guarantee will be met? And we want to give you opportunity to run your sensitive workloads with limited risk. So as I said, the goal of confidential compute around multiple industry vendors, all cloud providers, is to ensure that you don't have implicitly trust your cloud provider, and you don't have to trust our insiders. And we want to ensure that in addition to encrypting your data in transit, and by default, encrypting your data at rest, we one day would be able to offer you encryption of your data during processing in use. I think it will be a big deal for all of us, and we're definitely working towards that. And to prove it to you, we actually probably a year ago, a little bit less than that, shipped open source projects that we called Asilo. Asilo, we love Greek names, by the way. I don't know if you noticed it. And all these Greek names mean something. So this particular Asilo means that it's a safe place. We had plenty of discussions about that, you can imagine. So Asilo, the idea of Asilo is providing a tool chain and SDK for developers to create confidential compute apps. Because there is, again, for example, if you're familiar with Intel software, again, SGX, software guarded extension idea, Intel also has open source SDK, but it's a little more complicated to use it because you need or to start up from your fresh application, or you need to partition your more sensitive data and less sensitive data using Intel SDK. And not every single customer that I talk to actually know how to partition their very sensitive algorithm. So again, our goal is to provide much simpler tools that you can simply port your app from, again, your non-trusted app to trusted app and run it in Enclave. We finished up our confidential compute challenge literally on April 1st. It was not a joke. And we suggested that we will ask all community to submit, and we made it global for all people to, again, participate, to submit ideas how they will use confidential compute, Asilo, and cloud for their services, for their applications. And we were very happy to report back that we had very interesting submissions, and we will announce the winner very soon. So to move to the next topic, I want to summarize whatever you heard today. And the biggest key takeaways, I think, from our discussion and our session is we taking security very seriously, despite of the fact that we don't believe that one solution will solve and address every security issue you will have. We're building it from ground up, starting from our Titans and using Titans as our hardware root of trust to start building our security decisions and our trust chain. We extended this to vTPMs to give you your mini, tiny virtualized Titan. And you would be able to use it for your specific purposes, to have your virtual root of trust in your VMs. And we introduced Shielded VMs, and Shielded VMs today went GA. All my team exceptionally happy with that. And again, we believe that it's only first step toward make it shielded compute reality for all.